All right, this is a real attack using real source code from real contract. It was, however, put up as a joke on 4chan. They wanted it to be PoWHCoin, proof of work, PoWHCoin, they called it. It was just supposed to be a Ponzi, but they didn't think anybody would actually use it, but they put almost $1 million into it. And it turned out that in addition to being financially unsound as a Ponzi scheme, it had a flaw which you could use to steal all the money, and somebody stole all the money. So let's take a look at this one. In Remix, you need to get the source code, and the source code is 306 lines of source code. It's published publicly on GitHub. There it is. So, see if I can get it. How about raw? There we are. Now I can copy it and paste it easily. All right, and this should be called PoWHCoin. All right. So let's see if I've already got it here. I think not. I haven't done it in this browser yet. So I'll make a new contract. PoWHCoin. All right. And I'll paste in those 300 odd lines of code. Okay. And now compile it. And I can distribute it on a local JavaScript machine. I'm going to go to Berlin and back to London to get a clean blockchain, and then deploy it. And the transaction succeeds. And now I have some things I can do down here. All right. Let me go back to my instructions. All right. So we've compiled it and we've deployed it. Okay. And there's the things I can do here. So I fund it. I'll send 50 Ether into it in the fund button. Okay. So up here, I have my first account. That'll do. I'm going to send 50 Ether into the fund. So I'll be fund here. The transaction succeeds. My balance here falls to approximately 50. So those 50 went somewhere into the contract. Okay. Now I can view account. That's right. I see that the 50 dropped there. Now I can add another investor. This person is going to fund 1 Ether. So they're going to join this Ponzi scheme. They're going to invest. So the second person invests 1 Ether. Hit the fund button. The transaction succeeds. And this account falls down to 99. So that seems to be working fine. Now we have 2 investors, one that put in 50 and one that put in 1. Now, so the way transfers work from one account to another, you approve a withdrawal and then perform withdrawal into that account. Approve withdrawal from account 2 by account 3. That's the idea. So what we're going to do is, all right, we're going to select the third account, copy the account number, and go to account number 2. Okay, let's do that much. I want the third account, copy that number, and switch back to the second account. Okay. Now I have to approve transfer into that account here. So I go to the approve and I put the copied address in spender and 1 in the value. Okay. So now I'm trying to approve moving from account 2 into account 3. So I have approve somewhere. Here it is. Okay. So I'm going to put it in this address, which should be the third address. Let me go to the start of it. 4B should be the third address. And it is. Okay. And from the second address, which I've got up there, I'm going to allow transferring 1 Ether. So I transact here, and that succeeds. So that should have approved the transaction. Now, right, now, no money will have been transferred yet. I've just approved it. Now, to do a normal transfer, I would now transfer funds from the account number 2 into account number 3, and that would work. But this is going to be the trick. The trick is to transfer Ether from account number 2 to the contract instead and execute the transaction paying for the gas as account number 3. What happens is it's approved because it appears to be coming from account number 2, but it actually subtracts Ether from account number 3. This is the trick, and it comes from the developer getting confused about all these different account numbers. There's account numbers that come in as a parameter for these various functions, and then there's also message sender, which is the person paying for the gas, and they got them confused. So switch to account number 2 and copy the clipboard, then go down to transfer from and put it in from. Okay, so I'm at account number 2 in the from field. So it is here. There's account number 2, copy. And I want to do transfer from, and that is the to address. Okay. Now I want the, wait a minute now. Right, account number 2. That should be the from address. I'm getting it wrong. That's the from address. I'm going to take it from account number 2, and I'm going to put it in the contract address. So I get the contract address from here, and that goes in the to address. And you'll see when we look at the code why this works. Sending money to the contract address is the same thing as fund. So I ought to be using the fund button, and then it would work. But they enabled you to use this other process to perform the fund operation. And in those conditions, it gets confused about where the money's coming from. Now, I put in a value of 1, and now I change to the third account. So now I'm going to put in a value of 1 Ether going into the fund. But I'm going to pay for the Ether from this third account here, which has never received any coins in the Ponzi scheme. But it's going to try to withdraw from an empty account. That's the trick. So now I perform the transaction, and it succeeds. But now, if I look in the contract and go to balance of old, I can view various accounts here. And all I have to do is look at the third account, which is here. There's the third account. I copy it. And now the balance of old is here. And as you see, it's an incredibly huge number. This is another ridiculous feature of Solidity. This is an unsigned integer, 256 bits long. So if you have a 0 and you subtract 1, it turns into plus 2 to the 256 minus 1, this insanely large number. So by tricking it into withdrawing money from an empty account, I raised the balance of this account to essentially infinity, and now I can just withdraw money from there. And that's how they stole all the money. So let's look at the code, and here's the vulnerability. Here's the transfer from operation to send money from one account to another. But when this happens, it makes sure the transfer is no larger than the allowed value. And then it calls transfer tokens from to value. Now the transfer tokens function goes from to, and it checks to see line 114 here, make sure that's sufficient for the withdrawal. And we used account number 2 for that. Line, okay. Line 207, this calls the sell function. And the sell function here in line 211 takes it from message sender. This is the problem. It checked to see if I had the money in the from address, but it withdrew the money from the message sender address. And by my careful adjustment, I made it so the message sender, which is the person that paid the gas, is different than the from address. That's the problem. And this comes from trying to reuse functions. Instead of just forcing you to any transaction with the fund button, they tried to mix these different functions. So calling one transfer function will forward to another function under certain conditions. and they took a function that had 2 addresses and eventually forwarded it to a function that had only 1 address, and ended up losing track of the various addresses, making this attack possible. So the fix would be in line 117. If toAddress equals the function, then it would just call the sell function. But what it ought to do is just revert in that case. Say, if you are trying to send money to the contract itself, then don't use this transfer function. Just revert and force them to use the fund function, which is secure. That is one of the many ways to possibly fix this. All right. So that's another example of the kind of flaw you get and the consequences of it.